Good morning, students. Our today's topic is valency, isotopes, and isobars. So let's start with the valency. Students, we know that there are a number of shells present in an atom, and these are called first shell, second shell, third shell, fourth shell, etc. Or we can also call them K shell, L shell, M shell, N shell, etc. We also know that the electrons of the atoms are present in these cells. The electrons present in the outermost shell of atom are called valence electrons, and the outermost shell is called the valence shell. And from these valence electrons we can easily calculate the valency of a particular elements. So first of all we should know what is the valency. The number of electrons gained, lost, or shared by the atom so as to complete its octet is called the valency of the element. Or we can also define the valency that the combining capacity of the element is called valency. Now the next step is how to calculate the valency. For this thing, student, we should know two most important rules. The first is that if number of valence electrons are 4 or less than 4, then valency is equal to the valence electrons. And the second rule is if number of electrons are more than 4, then valency is determined by the subtracting the number of outermost shell electrons from 8. For example, look at the chlorine. Atomic number of chlorine is 17. So the number of electrons are also 17. Now we will write the electronic configuration of this chlorine, and that will be 287. So in outermost shell, chlorine has 7 electrons. So the valency of chlorine is 8 minus 7, that is equal to 1. Likewise, sulfur. Now atomic number of sulfur is 16, and the electronic configuration in first shell 2 electron, then 8, and the last shell is containing 6 electron. So 6 valence electrons are present in sulfur. So the valency of sulfur is equal to 8 minus 6, that is 2. One more example, we take the magnesium. Atomic number of magnesium is 12, and the electronic configuration is 282. So in outermost shell, 2 electrons are present, which are called the valence electron. And just now we have discussed that if the valence electrons are less than 4, means if 1, 2, 3, 4 are there, so their valency is equal to that number. So the last valence electron in magnesium is 2, so the valency of magnesium is also 2. So this is the method to calculate the valency. Now our next topic is isotopes and isobars. Student, isotopes are the atoms of the same element which have same atomic number but different mass number. Means that isotopes are actually differ only in the number of neutrons present in the nucleus. And if we'll talk about the isobars, then these are the atoms having the same number of nucleons but differ in number of protons. Means they have same mass number but different atomic number. Here we have some examples of isotopes, like the isotopes of hydrogen. There are 3 isotopes of hydrogen represented as you can see 1s1, 1s2 and 1s3. And these are called protium, deuterium and tritium respectively. Now you can see that each of them has atomic number 1. Each of them contain one proton in the nucleus, but their number of neutrons are different, and because of that their mass number is also different. So these are the isotopes of hydrogen. Now here we have some more example like isotope of carbons. We have three isotopes of carbon, that is the different in the mass number, because the mass number of one carbon is 12, then 13 and the 14. But all three isotopes have same atomic number, that is 6. Likewise we have isotopes of oxygen and uranium, etc. Now we have examples of isobars. Student, as I told you that such atoms of different elements which have different atomic number but same mass number are called isobars. Here we have examples: argon, potassium and calcium. Now they have different atomic number. Argon atomic number is 18, potassium 19 and calcium 20. But their mass number is same, which is 40. So these three are the isobars.